Hi there, I'm Hao, and this is just another video of me solving random numerical problem. So we need to match the alphanumerical pattern in a matrix. So we have a matrix like this, right? And pattern, the 2D pattern array, the 2D pattern. So a pattern is guaranteed to be a submatrix, right? So we're not gonna have like a pattern that is like bigger than the the matrix. And yeah, we just have to find the pattern, right? In the matrix that match the pattern given. So like in this one can represent A, right? And then two can represent B, right? So at every position where there's a number one, we can match that with A, right? Two would be B, two would be. And if we couldn't find the pattern, then we will return negative one, like this. Right? There's no pattern X and X, right? If you look at this, one represent X, but two cannot be also representing X, right? And vice versa, right? If we do find the pattern, then we will return what? Return the coordinate where the pattern start. Right? In this case, 0, 0. Okay, so this is pretty normal, right? We can just iterate over the matrix, right, and look at the patterns, right? Starting from 0, 0, right? Like this, like this. Let me change color here. This this pattern, right? Like this. And then like this. Right. So we just have to check every possible pattern. If we found one, we just short circuiting and return it. Right. Um yeah, so if the pattern have length 2, right? We can stop at index 1, right? Index 1 like this. Because if we the pattern start from the last column, then we don't have enough columns, right, to go through to match this pattern. Right? And another important point that you should notice is that we have this constraint, which is very important right here. If pattern R and C is a digit, then uh, pattern then the part RC must be the same digits, right? So for example, in the second pattern here, right, we found the pattern that match, right? 3 can represent A, 4 can represent B. But if it is a number, right? If the pattern is a number, yeah, if a pattern is a number, then the um matrix, right, must also be a number, right? It cannot have like a string 6 and a 6, right? If the pattern is a digit 6, then the matrix have to be also a digit 6 here, right? Not a string, right? Also like not some other random letters that represent it. Okay, so that is the only twist. So yeah, let's this is pretty mechanical. Let's work through it step by step. So the first thing is to return -1 and -1, right? If we couldn't find the pattern, right? So we just have to iterate over row and columns, right? Starting from 0, row is less than. Okay, so let's define some constant here. What do we have? We're gonna need the row and columns, right? Let's call this the B is for board, the board rows, B rows, and then B column, right? I just take the first letter here for denote thing, right? B row, B column, and here we're gonna have like the P row, which is P stand for patterns, and P columns, right? Equal to pattern length, and then pattern 0 length. So same for here, it is border length, and then border 0 length, just like that. Okay. So the row is gonna start from 0, and it's gonna go to up to and equal to B rows, right? Minus the P rows, row plus plus. All let column equal to 0, column less than or equal to p uh, columns minus p columns, column plus plus, right? Right. So for example, if the pattern have length 2, have 2 column, right? So if the pattern have the pattern right the two column, we're gonna stop at B row, which is 3, right? 3. Let's look at the column. So it's gonna be B column, which is 3 column, minus 3 minus P columns, which is 2, right? Equal to 1, right? So that's why we have the equal sign. We want to stop here, right? To process the last submatrix with a potential matching pattern. Okay, so let's say we're gonna have some helper method called match, right? Passing in the row and a column, right? So if it is matching, we will just return the row and a column, right? Because the row and a column here is the starting point of the pattern, right? Assuming we have a match helper match function doing something. Okay, so yeah, that is our framework, our setup, right? We're gonna have some constant. We're gonna iterate through every single submatrix, right? With the length same as the pattern length. And if they match, we're gonna return the starting point of the pattern. Otherwise, if there's no match, we will return -1, a -1, right? Okay. So the only things left to do now is to create this helper function, right? Match. Taking row and column. Let's call this one a star row and a star column. Star row and a star column. And we need a map, right? Because we need to represent the letters, remember? One is representing letter A, right? And A is representing number 1, so on and so forth. So that's why we need a map there. So let's do some follow here. So let row equal to star row, right? And row is less than star row plus the p rows, right? So we are starting from here, right? And we only want to go up to star row plus p row. So we're gonna go two to the two for rows and two for columns. Okay, same for the column. Let column equal to star column, column less than star column plus p columns, right? Because it is the dimension of the pattern. We only want to go up to the dimension of the pattern, starting from the star row and star column, based on the initial starting position. Okay, so we're gonna extract the b value, which is the value of the board, right, and the value of the pattern. The value of the board is pretty straightforward. It's going to be row and column, right? But what about the pattern? The pattern gonna be row minus star row, right? And then column minus start column. So plus plus, this one is plus plus. Okay, right. Let's say we are here, right? We're here, so the starting position is 1 1, right? So we can subtract the current row, right, from the start row, which is 1, right, and the start column, which is 1 here, to get to 0 0, right? So that we can compare this to this. Okay. So after we extract the value, we need to check if it is a number or not, right? So if it is a, so we're gonna convert the pattern into a number, right? If it is a number, right, then it will return an integer, right? But if we are trying to convert a string, let's say a letter A into a number, that is not a valid operation, right? So it will return not a number, right? So if it is not a number, which means it is a digit, right? So if it is a digit, then p value is different than p value, right? If the ball value is different than the pattern value, we will return false, right? Uh, Again, the else case here means that it is, so if it gets to the else case, which means that the p value here is a number, right? So if the pattern is a number, then if the pattern is a digit, then the board, the value on the board must also be a digit, exactly the same. It cannot be a string, it cannot be anything else. It have to match exactly, right? And how do I know that the p value here is a digit? I know that based on by converting the character into a number, right? If it is a number, if it is a digit in a string, right? Then the operation will success, right? If it is not a digit, the operation will fail, and this will return not a number. And if it is not a number, it is a digit. Okay, so that is the logic there. Yeah. So if it is just a regular letters, right? We're just gonna check if it is in map, right? If it's already in a map, we need to make sure that the values are the same. If it is not the same, then we will return false. Then we also need to do it two ways, right? Same here, p value in the map of p, p needs to equal to the p value. If they are different, then we will return false. Okay, and we're gonna put the value in there. We're gonna set up the relationship, right? All right, so 1 gonna represent letter A, and then letter A gonna represent number 1, right? Like this. So 1 and A, right? 1 and A, 1 p value, which is 1, represent A, and then A represent 1, right? Right. If we so if 1 represent X and X represent 1, and if we found number 2 here, right? We found pattern X is already in the map, and the map of pattern X is already representing 1. But in this case, it is 2, right? So we will just solve seconding and return false. Okay, so let's run this. Let's see. Expected 0, 0. Okay. Okay, this is correct list. Was it matching? Then we return the row and the column. Okay. Otherwise, -1, -1. Right. We return false in all of the invalid case, but we never return true in case it is valid, right? So if we iterate through the whole submatrix and they all match up, right? Then we will have to return true here. Okay, now it works. And thank you for watching.